All right. So let's start the discussion. Starting with, let's define what you mean by work. Okay. So what is work? Go ahead, guys. You can tell me.
So work is the amount of energy consumed,
Hmm.
like by an object to do something.
Energy consumed by an object to do something. Hmm? Nope. Come on, Riddhi. They have finished this for you in school. What is work?
Force into displacement.
Hmm?
Force into displacement.
Work is equal to force into displacement. Okay. I will move with that. Okay. We say in physics, work is said to be done. Okay. When you apply some force. Okay. And you are applying the force on an object, guys. Here, that H-shaped.
Sir,
Uh,
and the object should be displaced.
yeah. So this fellow is there. This H-shaped block is there. This H-shaped block is being moved by this gentleman. Okay. And how is it moving? It's not moving by itself. This gentleman is pushing it, isn't it? And he's pushing it with a force F. Okay. And under the influence of this force, okay, the object is moving through some distance d. Okay. So then we say, hey, this person is doing the work. And what is the work done? We say the work done is force into distance. Okay. See, what I'm doing is I will uh, come to you in various definitions of work I will be telling you. First, I will tell you the simplest one. Then I will add layers of complexity to it. Okay. So for now, I am going to tell you what is work done means. Work done is nothing but force into distance. Simplest definition first. But I will be changing it iteratively. The next step I'll tell something, in the further next step I will be defining it as different. Is it okay, guys? So we say work done, work is said to be done, okay, when a force F is applied on an object and the object is moving a distance of d under the influence of the force. I'll write it down for you. Okay. Aryan, can you read what I've written here?
Work is said to be done when a force F is applied on an object and the object moves a distance d under the influence of
Of
this
this
force.
force. Okay. So then you draw a nice diagram like this, that this force F is being applied. Okay. And the object is moving. Okay, and we say, how do you calculate it? We say the work done here is nothing but force into distance. For now, we will say force into distance. And I have, given one disclaimer as initial definition. Okay. All right. Guys, are you done making this small note? So if I say a man applies a force of 50 Newton and pushes an object through a distance of 15 meter, through a distance of 15 meter, what is the work done? What will you say for this?
225 Newton meter.
Yeah, you say W is equal to 15, that is the force, and distance also is 15. So we say 225 Newton meter. Okay, that is how we will calculate it. The next thing is this Newton meter is also known as, tell me guys. Sorry?
Joule.
Joule, correct. Joule. Okay. So you can say 225 joule because Newton meter, okay, is nothing but joule.
Done, sir.
All right. So now I will ask you one question. Okay. Supposing this force was applied like, a person is there on roller skates. Okay. And, someone pushed it. Someone pushed this guy or someone, used the leg and pushed this roller skate by giving a force of 10 Newton. Okay. And then this fellow is moving because he pushed him once, this guy is begun to roll. And let's say he traveled a distance of 10 meters. Okay. What is the work done here?
Work done by who? Work done by
Work
who?
done by this force, this 10 Newton force.
100 joule.
100 joule.
Okay, so this is where is the first catch for you. Okay, so this guy, he pushed just once. Okay, here there is no force being applied. Here there is no force being applied, isn't it? So this is one push. Cycle ko ek bar dhakka diya. Okay, and cycle started moving. The cycle would have moved some 25 meters, 30 meters. Okay, but if you say find the work done, you should not say the one-time force multiplied by distance. Okay, so if you observe the diagram here, I am put the arrows continuously until the entire distance d has been traversed. Okay, so that means force is continuously applied on the object and the distance d is being moved, like you are pushing a table across the room. Are you following this, Riddhi?
Yes, sir.
Okay, so one time push and distance moved you can't calculate work done in that way. Work done means that force is being applied throughout the distance. Okay, so that's the first what do you call alt concept, means that's the first thing you need to understand. Okay, this force.
So if you throw a ball, does it mean you're not doing any work?
Yeah, sorry.
If you throw a ball, does it mean you're not doing any work?
But
Yeah.
the ball is moving and you're applying force.
Yes. So you cannot calculate the work in that way, Ribas.
But work is being done, right?
Yes. So there you use something called impulse. Okay. So we will come to that. First is understand what I am discussing with you. Okay. So this force F has to be applied throughout the distance. Throughout the distance. Okay, means you can't take your hands off. Continuously उसको push करते रहना है. Throughout the distance. Okay. Only then can we say W is equal to F into D. Okay, give yourself an example. For example, if one guy gives just one time kick, this is like a one time jolt. Okay, a one time push, and later on, this person is just moving. There is no force being applied. You can't use the same formula and say 10 into 10, 100 Newton meter is the work done. Okay, and the key word is the force has to be applied throughout the distance. Did you understand this, guys? Tanush, are you making a note? I will ask you to take pictures of your notes and send today. So Arin and Tanush, please pay attention and note it. Then the second thing is, you will note that this force F is a constant force. Means you can't change. First I will apply 10 Newton, then I will apply 9.5 Newton. Work is done. But for you to use the formula W is equal to F into D, force has to be a constant force. Throughout the distance. Okay, there is a small confusion you may get. One is force has to be applied throughout, means you can't take your hands off. You have to continue to push. That's the first, thing which I'm telling you. And whatever push you're giving, that push cannot change. 10 Newton has to remain 10 Newton throughout your distance d. Okay, only then you can use the formula W is equal to F into D. Are you okay with this, guys?
Yes.
Yes.
All right. Okay. So that is the first part of our work done. Okay. Now let's move on to the next part. Supposing I now give you this diagram and say the person is applying a force, no doubt, is applying a force, let's say 10 Newton. Okay. And this baby or this child is indeed traveling a distance of something 10 meters. Okay. F is equal to 10 Newton and distance traveled is 10 meter. Okay. What will you say is the work done in this case?
We have to know the value of theta.
Wait, I will ask Aditya, I will ask Ranveer. I will ask Tanush. RL. What do you guys say? Do you think it is going to be 10 Newton into 10 meter?
Can you repeat the question again? Sorry, sir.
You please pay attention. Yeah, I can't keep repeating it. You can't have attention deficit and expect me to repeat it for you. Aditya, how is your leg, by the way, man?
Yeah, sir, it's better now.
Has the pain healed or still there?
I mean, I can't move it properly yet, but the pain has definitely reduced.
Have you they put some this thing bandage for you?
No, sir, but then they told me to take some tablets and put ice pack 2 times a day.
Okay. Generally, when ligament problem happens, no, you have to take rest.
Yeah, sir, they told me not to go for like 2-3 days, like not to move it much.
Okay. Tell me, what do you feel? Do you think work done here is 10 into 10?
Yes, sir.
So that is why I have given this as a second concept. Okay. So now I will ask Riddhi. Riddhi, when the force is being applied, okay, not in the same direction of the displacement or the distance, okay, because the object is moving like this. This is like when you go to the airport and you have a trolley suitcase, no? So typically the suitcase will be like this and it will have a nice handle, okay, and it will have wheels, okay, and you will apply the force in some direction and the suitcase will move in this direction, okay. Here the force is being applied continuously. You will not take your hands off the trolley, okay, but you know the trolley and the force, their directions are different, okay. So what do you think will happen in this case? Do you still think we can say W is equal to 10 Newton into 10 meter?
No, sir, because they're not being applied in the same direction. The force is being applied in a different direction and the distance is in a different direction.
Okay, so this is the second thing that you have to watch out for. Okay, so the first formula which I gave, the simple formula which I gave, W is equal to F into D. Okay, so this formula is valid, okay, only in special cases. So W is equal to F into D is valid for a specific case. Okay, what is that specific case?
Force and displacement are in the same direction.
Same direction.
The force and displacement are in same direction. Okay, for example, when I say a person is pushing the box towards the right, okay, so the force is in this direction towards the right, and the object is also moving in this direction. Okay, so now when I am talking about direction for distance, what is it that I should be using? Which word should I be using? Displacement, because now initially I said distance, but now I am telling force, direction, and the object's motion both should be in the same direction. Therefore, I can't use the word distance. I should say displacement. Okay, so then I will put this. I will say a displacement. This is a vector. Okay, and this is also in the same direction. Okay, so in that particular case alone, when force and the direction of the displacement are both in the same direction, means they are parallel, then only the formula W is equal to F into D is valid. Okay, can you please make a note of this? It is valid for a specific case. Okay, when is that? When direction of force and direction of displacement are in same direction. Ranveer,
Yes, sir.
initially you said you will not join, then you started joining. What happened?
Sir, I don't know, sir.
Today you are bugged, huh? You thought
Yes, sir.
क्या हो गया?
I don't know, sir.
You had some tiff with your parents, huh?
No, sir. Just mood is not fine.
Hey, when you see me, no, automatically your mood will become better. Okay. Show me your full face. Laptop ko thoda arrange. Huh?
Sir, can you see me?
Yeah, I can see you're looking handsome as ever. Okay, that smile, whenever you're down, no, beautiful 32 teeth you have to show to others. You see yourself in the mirror, force a smile. Okay, automatically your mood will change. All the grouse you have against Anand sir, teacher, society, parents, girlfriend, huh? Your dog, your neighbor, everything will vanish. Okay, so use these kind of you guys cannot afford to have bad mood, bad day. Huh? Always be cheerful and happy. Okay.
Yes, sir.
Hmm. Did you make a note of this? When direction of force and displacement are in the same direction, only then the simple formula W is equal to F into D is valid. Okay.
So,
If-
so when we're moving
Ah.
in different directions, like will we have to use vector concept to see which
Yes,
side?
yes. I am just coming to that. Okay. If they are not in same direction, if they are not in same direction, okay, and there is an angle between them, there is an angle between them. Ranveer, are you with me, baby? And when there is an angle between them, let's say theta, then the formula to use is W is equal to F multiplied by the displacement S multiplied by the cos of the angle cos theta. So this is the correct definition or complete definition of work done. W is equal to F into S into cos theta.
Sir, is cos hypotenuse by base?
So who is learning trigonometry?
Don't use base perpendicular. Do adjacent and
Okay. So here, if supposing we say this is F and we say this is S, okay, draw two lines, okay, and then you see the angle between them. This is called theta, okay. So you just say F, supposing I say theta is equal to 30 degree, okay, and I say force is equal to 10 Newton, and the object is moving a distance of 5 meter, okay, then you will say 10 multiplied by 5 multiplied by cos of 30. Are you following me, Aryan?
Yes.
So it is 50 into cos 30. Do you guys remember what is cos 30?
root 3 by 2.
Root 3 by 2.
Root 3 by 2.
Root 3 by 2. So you say 50 into root 3 by 2 or 25 root 3 joule. Okay, so have you guys noted the second part of it?
So 1 second. Sir.
Yeah. So when I say second part, I'm talking about when the force that is being applied and the object which is moving which is undergoing displacement in a particular direction, both of them are not parallel to each other. They have an angle between them. In such a case, the work done formula becomes W is equal to F into S. See here, S is a displacement because we are talking about distance and a direction. Okay, you can't say D, you have to say S. S is the displacement. And because it is a displacement, we can now define the angle between the two vectors. F has become a vector. Displacement is a vector. Two vectors can have an angle between them, and that angle is theta. Therefore, we will say W is equal to F into S into cos theta. All the diagrams which I am putting here, make a note of it.
Done, sir.
Alrighty. So for those of you who want to know, this is also called, if you say, I have a vector A, okay, like force is a vector. I have another vector B. Displacement is a vector, okay. I want to multiply these two vectors. Okay, this is called vector algebra. Two vectors have to be multiplied, okay. I can't multiply it like I do in simple math. Okay, for example, if force is 3 and displacement is 2 meter, okay, I can't say 3 into 2 is 6, okay. So in vector algebra, you have something called dot product. You say A dot B. This is not necessary for you, but if you're interested, you can learn it, okay. You say A dot B, okay. And the definition of A dot B is, what is the magnitude of A? Take it. What is the magnitude of B? Take it. And then whatever is the angle between A and B, take it. Okay, so the definition of A dot B becomes mod A into mod B into cos theta. Okay, so here you would have realized, okay, Aditya, tell me, what is the dot product which you are using here? What are the two vectors?
There will be force and then displacement.
So basically what you are doing here is you are doing F dot S, okay. So we say W is equal to F dot S, which is nothing but the magnitude of force. When you say 10, you are not telling 10 in the right side. You are just telling 10. That is called magnitude. This means magnitude of F, means just the quantity. When you say this means magnitude of displacement. You are not bothered about direction, okay? So this will become F into S into cos theta. This cos theta is taking care of all the directions here.
Yes, sir.
Okay, so this particular way of multiplying two vectors is called the dot product. Just as an information for you, this is not required for you to say anywhere in your answer sheets. In your answer sheets, you are supposed to just say it is F into S into cos theta, without getting into the details of dot product and all the rest of it. I am just giving it to you as an additional information. Shall we move ahead, guys?
Yes, sir.
Okay, so Ranveer will answer the question. So Ranveer, why did I change of force into distance as force into displacement?
Sir, magnitude.
No, Baba. I could have just said distance. No. Why did I change
Sir,
off?
vector force. Sir.
Yes. So the correct answer is this. You realize that the angle is important. The angle plays a part. Okay. You can define that angle theta only between two vectors. Okay. So therefore, the distance has to be represented as a vector. If you say distance, then it is a scalar. You can't have an angle between a scalar and a vector, right? So that is the reason why you want to represent the distance traveled as a displacement. And then you can define the angle between the vectors. Tanush, are you following this?
Yes, sir.
That's why we changed f into d as f into s into cos theta. Okay. All right. Now, let's come to the next level of information. Okay. So, Riddhi, can you read the slide for me?
Sir, I can't see your slide.
Oh, is it?
Oh, wait, I can see it now, sir. It was not loading for me. Okay. When work is not done as per physics, force without motion. When a force is exerted on an object which does not move, no work is done on the object. Force
Okay, so
perpendicular.
let's pause now. Okay, so many of you will have this question, no? यार, I am धक्का दे रहा हूँ लेकिन object हिल नहीं रहा है, right? So, but your muscles are strained. Okay, you are sweating. Okay, and you say, sir, I am applying the force. Okay, and I'm actually getting tired because I'm pushing the object. But physics says, bro, if you want to, I'm not doubting the fact that you're applying force, but don't ask me how much work I'm doing. Okay, but because in physics, if you want to say work done, object has to move. Are you following this, Aryan?
So because the object is not displaced, sir.
Yeah, the
Okay,
object
none.
is not getting displaced. No. So because the object is not getting displaced, even though you are sweating it out, even though your muscles are aching, even though you're applying 100 Newton force, we still say this person is not doing any work. Are you following this? Can you please make a note of it? This is case 3. When is work not being done as per physics? So finish the first case. I will talk to you about the second case in a bit.
That's
All right. Then, Ribhav, can you read the second, what do you call, picture? Second statement.
force perpendicular to the motion, constant velocity. When an object is carried at a constant velocity by a force which acts at right angles to the motion, no work is done on the object.
Forget about constant velocity. Okay, here the object is moving in one direction, force is applied perpendicular to it. Okay, so that is what you have to make a note. Okay, so please make a note that when you can make a note this way. When you have an object like this and some force is being applied in this direction, F, whereas the object is moving in this direction, S, okay, and the angle between them is 90 degrees. Here it is perpendicular. Theta is equal to 90. Okay. So in this case too, we say Bhaiya, work done is equal to 0, or work is not being done as per physics. Okay. So the first part we discussed was object is not moving. Okay. But force is being applied. There also work done is equal to 0. The second case, when the force and the displacement are perpendicular to each other also, work done is equal to 0. So the first case I said object not moving, s is equal to 0. The second case I said f and s are perpendicular to each other. Okay. Just make a note of this. I'm joining you in a minute. Guys, I'm back. Please turn your cameras on. All right. So, Arun, can you please explain to me how you can justify this? If uncle, you are telling force is there, displacement is there, but in this case, work done is equal to 0. Okay. How can you justify this?
So when it's perpendicular.
Perpendicular, correct.
I don't.
Okay, Tanush, how do you justify that?
Oh, so when you're adding force to the object in 90 degrees or perpendicular to it, so you're not adding the force to the object, but you're making the object part of yourself. I mean, like.
Doesn't make sense to me. Making the
Right.
object part of you means what?
1 second.
Shreyans?
So it's because cos 90 is equal to 0.
Cos 90 is 0. See, guys, we said work done is equal to F into S into cos theta, isn't it? This is the correct definition I said. Okay. So just apply this definition and say theta here. Okay. Here, the angle between the force and displacement is 90 degrees, isn't it? So if you take that F multiplied by S multiplied by cos 90. Arun, what is the value of cos 90?
Is it root 3/2?
You should know basic trigonometric values. Okay, Tanush, what is cos 90? Okay, Shreyans, what is cos 90?
0.
Cos 90 is 0. Okay, so this is why some basic things we ask you to remember. Okay, memorize, isn't it? Like cos 60. Cos 60 you should know is half. Sin 60 you should know is root 3 by 2. Okay, cos 0 you should know is 1. Cos 90 you should know is 0. So the basic standard values of trigonometric functions, right? Trigonometric angles, standard angles, and the cos, sine, tan, you should know these values. Did trigonometry taught to you CBC guys in 9th?
No, sir.
That's the reason why. But in physics, it is required. You know the definitions of sine, cos, tan, no? So along with that, there is a table. Okay, just make a note of this, guys, quickly as I speak. And for ICSE who already have trigonometry, it's a revision for you. Okay, I will only talk about sine and cos under various standard angles. Okay, theta is equal to 0, theta is equal to 30, theta is equal to 45, theta is equal to 60, and theta is equal to 90. Okay, so Ranveer, what is sine 0?
0.
Sine 0 is 0, cos 0 is 1. Okay,
1.
Riddhi, what is sine 30?
So 1 by 2.
Sine 30 is half, cos 30 is root 3 by 2. The root is only for numerator. It's not root of 3 by 2. It's a root 3 by 2. Okay. Shreyans, what is sine 45?
1 by root 2.
1 divided by root 2. And Ribha, what is cos 45? Are you in mute?
No, sir, 1 second. 1 by root 2. 1 by root 2, sir.
1 by root 2. Okay. Ribha, what is sine 60?
Root 3 by 2.
Root 3 divided by 2. And Aditya, do you know what is cos 60?
So is it 1 by 2?
1 by 2. Okay, and sine 90 is 1 and cos 90 is 0. Okay, so if you observe this, if you just learn sine, no, 0, half, 1 by root 2, root 3 by 2 and 1 in this direction you see. Okay, and put it for cos in the opposite direction. Okay, so it says 0, this is 0, this is half, this is half, 1 by root 2, 1 by root 2, root 3 by 2, root 3 by 2, and 1 and 1. Okay, so you say theta 0, 30, 45, 60, 90. If you just remember these set of values, okay, then you can reverse them and fill it for cos, and therefore you can start populating it for the other trigonometric identities like tan, cot, etc. Are you following this, guys? For example,
Yes, sir.
if I tell Aryan, find the value of tan 30, what will you do? Tan 30, what will you do? Tanush, what will you do if I say find the value of tan 30? Aditya, what will you do if I say tan 30? Are you there, Aditya?
Yes, sir. Sir, is tan hypotenuse by height?
Okay, so tan 30, the definition is tan theta is nothing but sine theta by cos theta.
Okay, sir.
So tan 30 will be sine 30
Sir,
divided by cos 30.
yes, so it will be half divided by root 3 by 2.
Yes, it is going to be half divided by
So
root
1 by
3.
root 3.
Yes, correct. So it will be 1 by 2 into 2 by root 3. So it will be 1 by root 3. Okay. So just learn till sine, cos, and tan. The definition of tan is sine theta by cos theta. Okay. Remaining things, CBSE fellows, I will not tell you, not required. I don't want to confuse you now, because trigonometry is not yet started for you. But till here, you should learn.
Yes, sir.
Alrighty. So therefore, if someone says, hey, a person is pushing the wall, what is the work done, right? You will say, yeah, this case is nothing but this case. The wall here is not moving, okay? Even though the force applied is a tangible force, is a real force, because the wall is not moving, this lady is not doing any work, okay? So when is work not done as per physics, we have covered, okay?
Sir,
Huh.
sir, isn't there another way in which work can be 0?
What is that?
So basically, when like you take a roundabout and you return to the same position, then displacement becomes 0, right?
I will come to that in a bit, okay?
Okay, sir.
I'll come to that in a bit, because that is another misconception, okay?
Okay, sir.
That is, many teachers in schools also teach you incorrectly, okay? So we will dwell that particular case in a bit. So Ribhav, can you please help me with this slide?
Okay, so the first one is work done in lifting own weight. So here force and displacement are in different directions.
Okay,
So we
Ribhav, you have to speak clearly. Okay, speak clearly. What do you see here? This girl has to climb the stairs, okay,
Yes.
and reach the top. That's the activity she's doing, okay? So what is she lifting? Is she lifting physically anything?
No, her own weight.
She's carrying herself, isn't it? Means if you look at the heart as a machine, okay, the heart is, whenever you climb the stairs, you feel the heart is beating more, no? Dab 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 dab, thoda zyada beat karta hai, okay? So that means the heart is doing the work. The heart is the machine for you. Okay, so I am talking if the person is climbing the stairs, first of all, is work being done? Okay, so let us take that as a case. When a person of mass m is climbing a flight of steps, okay, is work being done?
Sir, I think it's zero work being done.
It is zero work being done. Can you justify and say why?
Sir, when you're climbing up the stairs, like the force is being applied in the upward direction, so that you can like move your legs up and then you can move, and then displacement is going forward because you're moving forward. So when in the second case, when the angle between force and displacement is 90 degrees and it's perpendicular, then work done is zero.
Okay, so that is your explanation.
Force acting downwards.
Hold on. Okay, so
the weight is the force you're lifting upwards.
Wait, we will discuss that, Vibhav. Just give me 1 minute. So, Aditya, please pay attention. Tanush, Arin, please pay attention. Okay. So, if there is a person who is lifting his own weight, okay, and he is walking in this direction, okay, if you want to kind of make it more realistic, you can also put a mass on top of this person's head, okay? A person, or generally we say coolie, okay? A person who carries the luggage and helps us in railway stations, right? So that coolie is either carrying some mass or he's carrying his own weight, okay? And he is walking, okay, within the same platform. Do you think he's doing work in carrying the load?
Yes, sir.
Why? How?
So, as in, if he's moving around, that means he's going in one straight line, right?
Yeah. So let's say he moved a distance of 10 meters. And let's say
Yes,
the
sir.
mass is equal to 3 kg. Okay. What, as per you, is the work done?
Zero.
It is zero. Why?
Sir, because then like weight is acting downwards, and that'll result in the thing being 90 degrees, and so it'll be zero.
Okay. So see, you have to think from man's perspective, this person's perspective. Okay. How is person applying force? Okay. So here it is not a push, it's not a pull, it is a lift. Okay. So the weight is acting downwards. So the person is trying to resist it by applying the force upwards, isn't it? So when you're carrying luggage, when you're carrying a suitcase, isn't it? The suitcase is trying to pull your hand down. Your hand is trying to lift the suitcase, isn't it? So from the person's perspective, the force applied is the lift. Are you following this, Aditya?
Yes,
The force is applied upwards. Okay, weight is acting downwards. Force is applied upwards. Okay, so similarly here, when the mass, this fellow is carrying a mass, the weight pertaining to that mass, m into g, 3 into 10, is acting downwards. It's acting on his neck muscles. Okay, and the man is trying to resist it by applying a force on the upward direction. So this is the force applied by the man. Whether it is the neck, whether it is the legs, it doesn't matter. The man or the person is applying the force in the upward direction in order to overcome the weight. Tanush, are you following this, my dear?
Yes, sir.
Okay, so you rightly said this is the force being applied by the person, which is equal to W, and this is the direction he is walking. and the angle between them is 90. Therefore, this is the case we saw perpendicular forces work done is equal to 0. Are we clear?
Yes,
Okay.
sir.
Make a note of this. This is a case when a person of mass m is carrying a load and walking, okay, straight. So I'm
So
not
this is
talking.
the same
Hold on,
case when
hold on. When a person of mass, okay, when a person is carrying a mass करके change कर रहा हूँ. When a person is carrying mass m and moving along x-axis, okay, means is moving horizontally. Work done is equal to 0 because the force is applying and the displacement are at 90 degrees to each other. Let me know if you're done.
So is this the same case that applies to walking up the stairs as well?
No.
Yes.
That's why I erased it. Because for me to answer Aditya, I have to first make him realize this, then I have to tell the second case. All right.
It's like cancelling.
What cancelling? No, it's not cancelling, my dear. See, we always observe how the force is being applied. Okay. So the force being applied by the person is in this direction. Okay. And how is he walking? He is walking in this direction. Okay. Why is the person applying the force in this direction? Because the weight is acting downwards. Okay. He's applying a force equal to the weight, but in the opposite direction. Tanvir, are you following this?
Yes, sir.
Because to calculate work, the first question you need to address is what is the force being applied by the man, by the person? Okay. Because if they say a person is carrying a load of mass 3 kg, okay, there you can calculate W. W is equal to M into G, 3 into 10, okay, 30 Newton. But how will you calculate F? Okay, the justification is F is equal to W. But F is in the upward direction. The force applied by the person in lifting the load is 30 Newton upwards. Tanush, are you following this?
Yes, sir.
Okay. Aditya, did you get this first case?
Yes, sir. I understood the first case.
Okay. Now I will tell you the second case. Case 2, when a person is carrying a load on the head, okay? Carrying load on head. Now let's assume that same person is carrying the load, okay, and somehow he's scaling a wall. Okay, don't ask me how he's doing it. Maybe think he's like a Spider-Man and he has some techniques because of which he's able to scale the wall up. Okay, it's a perpendicular wall and the wall has a height of 10 meters and he's carrying a load of 3 kg. Okay, now do you think the person is doing work?
Yes, sir.
Why?
Sir, because this time he's applying constant force parallel to the height of the wall, so therefore it will be moving.
Riddhi, do you agree to what Aditya says?
Yes, sir, because the angle also between them is not 90 degrees because he's not like directing the force above his head. He's
Hmm.
just walking the same direction. So
Yes. So we will say, yeah, this 3 kg is the weight acting downwards. So our dear person has to apply the load using his body, his neck muscles, his waist or legs or whatever. That means he's applying the force in the upward direction. And he's also moving vertically. This direction he's moving. So direction of force and direction of motion, both of them are parallel to each other, isn't it? Here our F is parallel to S. Because when you say displacement, displacement is up along the y-axis. Direction of force is also along the y-axis, positive y-axis. That means, Rn, what is the angle in this case?
Where it is 0.
0, because both these fellows are parallel to each other. Theta is equal to 0. So, in the case when the person is carrying a load and somehow he is doing a vertical climb, okay, that then work done is not 0, okay, work done is equal to the load, okay, that 30 Newton multiplied by this height, which is 10 meter. That means he is doing 30 Newton meter or 30 joule of work. Ranveer, are you able to follow the person carrying a load case?
Yes, sir.
Carrying a load walking horizontally means no work. Because carrying load upwards, walking horizontally is along the x-axis 90 degrees. Carrying a load and going up means work is done. Because carrying a load is upward, walking up is also upward. Both of these are same direction. Theta is equal to 0. W is equal to work done is equal to force or the weight here multiplied by the distance, vertical distance.
Sir, I think I understood my mistake.
No problem. One by one step at a time, we will do it. You will
The
learn.
30 Newton into 10 meters is equal to 30 Newton meter. How does that make sense?
Sorry, bro. Permit me these stupid mistakes. 300 Newton meter or 300 joule. Thank you for that. Shall I move ahead, guys?
Yes, sir.
yes, sir.
Okay. Tanush, have you made notes here?
Yes, sir.
Okay. Now I will ask you case 3, which is the question which I wanted in the first case. Okay. The girl is going up the flight of stairs. They have given the overall height here, 5 meter. Do you think she is doing work?
Yes, sir.
Yes, sir.
Okay. What is the work she is doing? So I am writing this case 3. Person climbs a staircase. Okay. Staircase. Or they will also say flight, a flight of stairs. Person climbs a staircase. Is work being done? Okay. Justify this, Ranveer. Why do you think work is done here? First of all, is work being done?
Yes, sir.
What is the force the person is applying?
The force is also up and then he's moving up.
But what is the force? What is the force the person is applying? उसके सर पे तो कुछ लोड नहीं है, वजन नहीं उठा रहा है वो.
Sir, the weight?
बराबर. Okay, because see, the person is carrying his own weight, no? Okay, he has to carry his own weight. Okay, therefore we say even if he doesn't have a mass on the head, okay, is a person doing some work? We say yes. Okay, he or she has to carry their own weight. Okay, so if they say the person is 40 kg mass, person is 40 kg mass and climbed 5 meter stairs. What is the work done, Riddhi?
So don't we also have to consider the angle?
Okay, but assume it is now directly climbing.
So then it'll be 40 into 5, which is 200 joules.
Okay, one word of caution. Aditya, is she right?
Sir, if she's directly climbing and she has no mass over her head, then the angle between them is 0. Then won't the work done be 0?
She's climbing, no, right? Climbing 5 meters, vertically climbing, you think.
Oh, so yeah, then she's correct.
Aditya, Ribhav, is she correct?
Sir, I was not here. What did she say?
I can't repeat myself. Shreyans, is Riddhi correct? Tanush, is Riddhi correct? See, girl, this is 40 kg. 40 kg is mass.
Oh, it's not force.
So you always think of force, okay? So if I had given her weight is 40 kg F, or if I gave 40 kg mass, you should say 40 into 10. That will be her weight. Therefore, she has to, when she is pulling herself up, she has to apply a force of 400 Newton. 400 Newton multiplied by 5. So 2000 Newton meter is the work she is doing in carrying herself up.
Yes, sir.
Carrying herself up.
So, but if it was 40 kg F, do you still multiply it into 10?
Yeah, if it is 40 kg F, if you want to express it in joule, then you have to convert it into Newton, no? So you'll say 40 into, for F you will put 9.8 or 10 if it is permissible. Convert it into Newton because you know 1 kgf is 10 Newton. Therefore 40 kgf is 40 into 10, 400 Newton multiplied by 5, 400, 2000 Newton meter.
So it's the same case in both.
It's the same case, yes.
Yes.
Because you don't say 40 kgf into 5 kgf meter. You have to tell Newton meter. So even if you get kgf meter, convert kgf into Newton. Using 1 kgf is equal to 9.8 or 10 Newton if it is permitted. Okay. Now, this is an imaginary case. How can the person crawl the wall? Actually, she is climbing a flight of stairs. Okay. So, same case, a person is having 400 kg mass and they are climbing a flight of stairs. What will be the work done here in this case?
So work done here will the work done here will also include the angle, right?
Okay.
Because
what angle you want, I will give you the angle. If you want to know the angle between the steps here and this, I will say 30 degrees.
So then it will be force times height into 60.
Okay, so here tell me what is that 30 or 60?
So the
If
angle
you
between
wanted an angle, I gave you an angle.
so the angle between the flight of stairs and the ground.
But why do you need angle between flight of stairs and ground? See, you need the angle between the force and the displacement, isn't it? So how is she applying the force? How is this person in climbing the stairs applying the force?
So downwards.
Downwards.
Downwards, isn't it? She is pushing the ground in order to climb up. Okay. So, and flight of stairs. So if you look at this flight of stairs, no, this is like a compound movement. For example, across the steps, okay, she is walking horizontally like this. And then when she's climbing the steps, she's doing like this. Are you following this?
Yes, sir.
So assume this for a minute that this step is like a long step. Okay. Just for us to understand. Let's say this is a 3 meter long step. And this height is, let's say, it is 3/4 meter tall step. Okay, 3/4 meter step. The length is this thing. Okay, so assume she has to first walk like this. She has to walk across the step and then she has to climb the step. Are you following this? So each step is composed of both these two. I will call this as motion A, and finally climbing is motion B. I'm splitting her, her act into two. Okay. Now for A, what do you think is the work done?
0.
0, because she's carrying her own weight and she's walking horizontally across the step. There is no work done. So all the work that she's doing is when she's doing the climb, isn't it? When she's actually traveling 3/4 meter per step. Here, the force is applied in this direction. The climb is also in this direction. Are you following this? So
Yes,
the
sir.
angle truly does not matter because the weight that she's overcoming and the climb are always parallel to each other. During the climb, during the walk phase, she's applying the force in this direction and she's walking across the stairs in this direction. So this is 90 degrees. So this component A is 0. Finally, when she's climbing, that is the work done. Are you following this? Okay, there you will say, uncle, she's her weight is 400 and she's climbing 3/4 of the step. So 100, 300 joule is the work done for climbing one step. Okay, and if she has to climb 10 such steps, you will say 300 joules into 10. So she has to travel 3000 joules. This is number of steps I've given. Does it make sense?
Yes, sir.
Okay, so climbing the steps, you don't need the angle. You're not bothered about the steepness. Okay, all you need to know, if you realize here, is what is the overall height that she's climbing. If I've given it as 5 meters, and if I'm saying that the weight of the person is, 40 kg, so 400 Newton her weight multiplied by 5 meter, the overall height is what we need. Because see here, this height plus this height plus this height plus this height plus this height. All these heights, if you put together, is nothing but 5 meter. Aryan, are you still there? Are you following what I'm saying here?
Yes.
So if there was a slope without any, so if there was slope, then
Very good question. Yes.
distance.
Yeah. So because he's telling, what if there is no step and it is a disabled friendly ramp? Okay, this is a ramp and a person is walking up the ramp, right? Still, we will be considering only this height. Because whenever you're traveling the ramp, even though the ramp is like a straight line, you can think of it made up of multiple teeny steps, okay? Where each height is like, very small. It's not like a big step, but it is a continuous. So here too, you are bothered only about the overall height. Okay, so irrespective of the distance that person is moving, she may be moving 30 meter. Okay, but the vertical climb she is doing is only 3 meter. Okay, so we will say the force she is applying is her own weight and she is also climbing 3 meter. Therefore, her work done in climbing herself, in pulling herself up is W into 3. Are you following
Okay,
this?
sir.
Okay.
Yes, sir.
Yes.
All right. Now comes another case. What if we are...
Sir,
Go ahead.
so can I take a break?
Okay, go ahead, take a break and come back, guys.
So you consider
You have
the
to do the weight
mass
into
as
height
well?
because you're applying the force to resist the thing on your head, and you're also displacing yourself upwards. So it's just the like your weight to combat that into the height side.
So what are you saying? Can you just say in short, what is it that you're saying?
Force and displacement, same direction, hence you multiply your weight with
What is the force here?
your weight.
That's why I said work done by person in lifting the load. I have put...
Consider weight as well as the mass, like what she's carrying.
No. So when they specifically give like this, then they are saying, don't consider the work done by the person in lifting themselves up. Okay, so that is there. Load ke liye, specifically for lifting the load, what is the work done? Okay, if they ask the question, what is the work done, or let's say total work done by the person? Because
So
this is
then it is weight and mass.
total work done by the person, they can ask in this way, or they may say work done in hauling themselves up, okay, in lifting themselves up, plus lifting the mass. Okay.
Yes, sir.
So if in either way they ask this question and they give the mass of the person, okay, they may say the mass of the person is 40 kg and they may say the load that she is lifting is 3 kg. Okay. Then what you do, you sum it up. 40 plus 3 is 43 is the total mass, herself and the load. Multiply that with 10 to make it into weight. And then multiply it with the height. Supposing they are traveling 5 meter. Okay. That will be the total work done. Okay. Or work done in lifting themselves up plus lifting the mass. Okay. But if the question is like this, find the work done by person in lifting the load very specifically. And the clue to you would be they would not have given the person's weight. Okay. So there, don't get confused. Just say that load M multiplied by G. In this case, it is 3 into 10, 30, plus multiplied by the height climbed, whatever it may be. Okay, 5. 30 into 5 is 150 Newton meter. Are you following this, guys?
Yes, sir.
आर्यन आपको समझ में आ रहा है?
Yes.
So, do you understand Hindi, or sometimes I break into Hindi here and there?
Yes, sir.
सिर्फ लोड को कैरी करने के लिए कितना काम कर रहे हैं, अगर ऐसा पूछा तो सिर्फ लोड का लेना है, खुद का वजन नहीं लेना है. But if they say what is the total weight done by the person, total work करके, if they use the word total, and they happen to give the mass of the person also, then you should know work done by the person is nothing but work done in lifting themselves up plus work done in carrying the external load. It is a summation of two. Okay, but if they're just done work done by the person in lifting the load, don't take the person's weight into account. Okay, just take the mass of the load multiplied by G multiplied by the distance climbed. Did you follow this, guys?
Yes, sir.
Yeah.
Okay,
Yes, sir.
so these are all some of the things that you could get confused easily. Therefore, we are discussing this. Okay. Then the other cases. Okay. If supposing you have a ball and you are attaching the ball to a string, and then you are putting the string around your finger, looping the finger around your finger. Okay. This is your hand. Okay. And then you're doing this round, making it to go round.
Sir, we can only see the presentation.
Oh, thank you. Because I've been writing all these things here. Okay, maybe you can just make a note of it. Work done by a person in lifting the load. Okay, so you have to answer this question in two ways. If they ask what is the total work done by the person, then it is one case. Okay, work done by the person in lifting the load, only lifting the load is one case. Okay, so you might have to answer the question based on that. And now comes this particular case.
So it all depends on the question.
Yes. I will give you a sample question so you will clearly know how it needs to be done. Okay, so the next case I'm discussing is the case of a person twirling a mass around a circle and the object is tied by the means of a string and the string is tied to the finger like this. Like
The
Vishnu.
first case was actually pushing the mass, right?
Sorry?
The first case was pushing the mass, second case is twirling it with a string.
No, where are you locked up, my dear? Where are you? Here. So I am talking about this particular case you're talking, no, Ribu?
No, sir. I wrote down one. You said there are two cases. I didn't.
So that's what I'm sharing the notepad. And in the notepad, I had written total work done by the person. So you're discussing about this case, right?
No, sir. You gave another example downstairs.
No, this example which I'm talking about is a person having a mass and going round. Okay.
There'll be
Sir,
no
he's
work, right?
asking what case number it is, sir.
Oh, that case number. Okay. So chronologically, if you see here. So I discussed about a person just lifting themselves up a flight of stairs. Okay. And then I am telling that this person has a mass on top of the head. Okay. So the case that I'm discussing, I wrote there is this. So if they have a load on top of the head and climbing here, are you able to see this? Above?
Yes, sir.
Okay. Here, if I say, if the question is find the work done in lifting the load. Okay, when the person is going this way and they have reached here finally. Okay, so when they are work done in lifting the load, don't consider the weight of the person because they are specifically saying वजन उठाने के लिए उसने कितना काम किया है.
Yes.
Okay, so here you will only be considering the mass of the load multiplied with the G in order to get the weight. Okay, the weight of the load is acting downwards. So the person has to lift against it. He has to apply the force in this way, which will be equal to mg, 3 into 10, okay, multiplied by the overall height climbed, 5. Are you following this? Okay,
Yes,
so
sir.
this is one case they may ask. The second, they will reword it as find the total work done by the person. Okay, so look out for the word either total or look out for work done by the person in hauling or lifting themselves plus the mass. Are you following this? Okay, so if the question is like this, a person is carrying a mass of 5 kg and climbing a flight of stairs, height of 6 meters. Okay, just make a note of it. Let us do a numerical. Okay, a person of mass 50 kg is carrying a load of 3 kg and climbing steps to a height of 6 meters. Make a note of the question, please, Riba. Followed by two questions. A, find work done by the person in lifting the load. And B, find the total work done by the person. So, Riba, what would A be for you?
So it has to be just the load's weight. So 3 kg is the mass of the block. So you want it in Newton. So you have to do 3 into
I don't want it in Newton. Work done requires force.
Yes.
The force is nothing but the force applied by the body overcoming the weight, isn't it?
Yes, sir.
To overcome the weight. The weight is going to be how much?
Weight is going to be 30.
When I put F suffix L, it means load, okay? 3 into 10 is going to be 30. What above?
Newton.
30 Newton, okay? So, therefore, the work done in carrying the load
Work done carrying load is 30 Newton into 6 meter.
will be 30 Newton into total height climbed 6 meter, 180 Newton meter. Where ml is nothing but mass of load. And WL is nothing but weight of load. Okay. Now, Shreyans, what will B be?
So I just came back.
Aha.
I went to the
No,
washroom.
no, he told me.
Okay, no problem.
So,
Aditya, what will be B?
Yes, sir. So here we have to consider the mass of both the load and the person. So it'll be 50 plus 3, which is 53 kg. So the weight will be 530 Newton. And then you multiply that times 6.
Total mass is 53. Therefore, total weight
so
is 530. Therefore, total work or work done in lifting themselves along with the load is 530 multiplied by 6.
3180 joules.
3180. Now is it clear, Vibhav?
Yes, sir.
So always read the question completely, slowly, don't be in a hurry. Note down what is it you are asked to find. फिजिक्स में खामोखा वो कंफ्यूज करने की कोशिश करते हैं, तो जल्दबाजी कम कर दो. Okay, because until you gain that maturity in answering the questions, don't rush. Don't see some fancy values, remember formula, try to apply that. You have to break it. Okay, try to put some small diagrams which will ensure that you are translating the question into a small bit of analysis for yourself. Then ensure you are applying the concepts correctly in answering the questions. Okay, so I always recommend put given first and then put what is it that you have to find. Because sometimes they will ask you to find 2 things or 3 things. You may get the final answer, but you will miss putting. Therefore, this part A answer is so many meter. Part B answer is something. Part C answer is something you may miss. Then you will lose marks. Always put yourself to find. To find is like a checklist for you, not to miss out. Especially for ICSE, where one question will have multi-part. Are you following this?
Yes, sir.
Already.
So you have to solve it in parts.
Yeah, you'll have to solve it in parts. Okay. And also, before even you solve it, you just put this, given mass of the load is equal to 3 kg is equal to 30 Newton. So you can, when you put the given, you kind of take care of the conversions also. You're forcing your mind to think in these steps. I will put given. When I am putting given, I will ensure I pay attention to the conversions. Okay,
Yes, sir.
I will put to find. In to find, I will put all the things which are necessary to find. And then I will start doing my statements. Do you follow this, guys?
Yes, sir.
Alrighty. So now coming back to the case that I was discussing, a person having a mass around the finger and turning it round and round. What do you think is the work done?
0.
Why?
So because no displacement.
So
The displacement is 0.
okay. So this is where another alt concept or misconception. Okay. So Aryan, work with me. What is the force here?
So what?
What is the force here? How is the person applying the force?
So he's turning the object.
Yeah, but how is the force being applied? Have you thought about it?
Sir, circular.
Uniform circular motion. How is the force being applied? उसको कहाँ से
Sir,
Hmm?
outwards.
No, you imagine, no, you are having a string. You are turning it round and round. Okay, you imagine yourself doing that. Anush, you want to take a try? Ranveer, you want to try?
Sir, is it horizontally?
Where? The person's only finger is there, no? How is he applying horizontal force?
Sir,
What
can
is
I?
the horizontal force?
Sir, you put it to one side and then start messing.
You think that the thing is already started. Because force has to be applied constantly, no? It's not a one-time force, right?
Sir, can I?
So is he focusing his force to one point in the middle?
I want you to tell me what is the direction of the force. What is the force?
So opposite to
What
the
is the direction of the force?
So opposite to the object's inertia of direction.
तू मेरे को गोली दे रहा है यार, बहुत गोली दे रहा है. Think physics is very concrete. You do not confuse it with terminology which you yourself don't understand. Keep physics very simple.
Sir, is it towards the center?
Correct. This fellow, no, you think, you know, when you take the force and you want to turn it, you are applying force towards yourself. Means you're pulling the object actually. Okay, as you pull the object starts to turn. Okay, so the force is nothing but the tension in the string. Are you following this, guys? The force is not horizontal, the force is not vertical. The force is the tension, the pull that you give. And the pull is not in one direction. You keep pulling it in different directions. First, you will be pulling it towards yourself. Then you will be pulling it in this direction, this direction. The pull is changing. Okay? And the object is moving like this. You can say the pull is the tension in the string along the radius. Okay, please make a note of this. Okay, I will erase the remaining part and I will write the explanation for this. I will draw the diagram here, guys.
Yes, sir.
Okay. The force being applied by the person is the centripetal force. This kind of force is called a centripetal force. Okay. Also known as the tension in the string. Okay. That acts along the radius. Okay, and in a simple diagram, you just show one snapshot. You say this is the centripetal force or tension T, and the object is moving in this direction. Snapshot. So you say displacement and tension are perpendicular to each other. Okay, so here this is an example of a case where force and displacement are perpendicular to each other. Okay, so the minute the object comes here, this is the direction of motion of the object. Okay, and this becomes the tension. Once again, they are perpendicular to each other. So at every step, this I'm not drawing it very correctly. So at every step, the displacement and the tension are perpendicular to each other. Are you following this, guys? Above, Riddhi?
Yes, sir.
Okay.
Yes, sir.
So the work done is zero, not that the displacement is zero. Don't say that, when the object is moving one full round, the displacement I know is zero. It is not for that reason, but for the reason that the tension and the the motion of the object, the direction of motion of the object, they are perpendicular to each other.
This will be 0 and then it'll be.
Therefore, it is zero. Okay.
Sir, I have a question.
Go ahead.
So what if an object is in a linear motion and then comes back to its original position? So
Yes.
in that case, can we say that because displacement is 0, then work done will also be 0, or?
No, we can't.
Okay. So
Because
the
like
answer is, the answer is no. Reason is, see, while you say conveniently work done is equal to force into displacement. Okay.
it's only because like a vector.
Yeah, you want to say that, force and displacement and the angle between them I want. Okay. Therefore, I define this distance as a displacement. Okay. But you just imagine if I am pushing the object like this, like the case you told, you are moving from point A to point B. Let's take your own case, Aditya Nadkarni. Okay. You applied all the way here. You are sweating it out. You came here. Okay. So you say work done in moving the object from A to B. Let's assume that it is some 100 Joule. Okay. So you are applying a force of 10 Newton and you have moved it distance or displacement of 10 meter. Is it okay? WAB is 100 Joule. Now you see here, you are applying the force in this direction and you are moving back to the original position like this. Okay, here the force is towards the left and the displacement is also towards the left. Are you following this?
Yes, sir.
Therefore, if you look at it, this is the force, this is the displacement. Both of them are parallel to each other. Theta is equal to 0. Angle between them is 0. So this will be again another 100 joules. This is work done to get the block from B to A, vapas. Okay. Therefore, total work done will be equal to work done to move it from A to B plus work done to move it from B to A, which is equal to 200 joule. Are you following this?
Okay, sir.
So don't take displacement as the overall entity here. Like, isne A to B gaya, B to A aaya, total displacement is 0. Don't think of it like that. Displacement is a vector. You need to know, this fellow when he's going from A to B, he's traveling in this direction. He moved this much. What is the work done? He moved this much. What is the work done? So you're breaking it up into incremental steps. And then you say, Abba, I calculated the work done for the onward motion. Now this fellow is turning back. How is he applying the force? How much is he moving? So you're calculating. Small portion you're calculating. Overall, you calculated over B to A. Add them up.
Okay, so we have to divide it into parts and then calculate.
Small parts. Okay, small parts and do. Okay, don't look at displacement as an overall plus 5 meter, minus 5 meter, and say 0. That's not how he's doing it. No. The word displacement is there for you to get the angle between the force and the distance moved, isn't it? Here the angle happens to be 0.
Okay, sir.
Okay, so for the same reason, if someone says a person is moving right by pushing a block, and then he takes a 90-degree turn and pushes the block here and reaches the point B. And let's say this is 3 and this is some 4. Find the work done. This is 3 meter, this is 4 meter. This is not vertical, this is L shape. A person is traveling L shape along the ground and is applying a force of 10 Newton. What is the work done here?
10 times 3 plus 10 times 4.
Very good. Okay. So you're going from here to here. Find out how much that is. 10 multiplied by 3. You're taking all the work done to move this distance. You're very carefully considering the displacement and the force applied. Both of them are in the same direction. Then you're taking a 90-degree turn, moving towards the left or maybe towards the right. Okay, doesn't matter. And for that, you are again applying the force in this direction and displacement also is in that direction. So it is 10 into 3 plus 10 into 4, which is 30 plus 40, 70 Newton meter. Work done in this case is this. Okay. Do not calculate the displacement here and say displacement is 9 plus 16 under square root of 25. Square root of 25 is 5. And say 10 into 5, 50 Newton meter is the work done. That is a wrong way to calculate work done. Because the term displacement, you should think of it as distance, but you can't use the word distance because if you use the term distance, it is not a vector. I need to be sure of the angle between the force and the motion. Therefore, for all practical purposes, think of distance, but for the purpose of angle, think of displacement. Okay, and calculate the work done. Are you following this?
Yes, sir.
For the same reason, if you have a circular track, okay, and you are pulling some golf cart, supposing you have a golf cart, okay, and you're pulling the golf cart along the circular track and made one full round. And they say the radius of the track is 2 meters. Okay, and the mass of the golf cart is 10 kg. The cart plus the golf clubs, the golf balls is 10 kg. Find work done. What will you do? He reaches the same point.
The displacement is equal to 0.
Displacement is equal to
0.
अरे भैया अभी तो वही
Sir.
Hold on. रणवीर, तो displacement 0 करके नहीं बोल सकते दादा. In the previous case, when a person is walking straight and then taking a left turn, we didn't calculate displacement, no dada.
Alright, but you can't.
Okay, you actually, when you're doing this, see, you took 10 into 3. This is the distance along the x-axis. This is the distance along the y-axis.
Yes,
okay, it's
we
going straight and then you took a
calculated
turn. We are taking this as two independent distances. We never calculated displacement.
Yes, sir, but you have to use vector, so we say displacement.
Yeah. So similarly, in this case too, Aditya, you wanted to say something? All of you
Yeah,
turn
sir.
cameras on.
So here we have to assume that the displacement is the displacement will be along the perpendicular to the radius, and then we have to say that due to the second case, since the angle between the radius and the
Hold on. No,
Oh.
you're wrong. Riddhi, you want to say something?
Yes, sir. So we just never consider displacement as zero because you always consider
No. Rebuff.
So we basically like the force is acting along the radius and you're moving towards
How is
like
the force acting along the radius? See, bros, you think of this. A person is pushing a golf cart along a circular
for
track.
this for
Hold
this
on,
example.
hold on. Because you guys are being totally...
No, sir, for this example, you do 2 pi r into f.
No, see, a person is pushing a golf cart along a circular track. Are you able to picturize this?
Yes, sir.
So this is the golf cart and he's pulling the golf cart like this. This is the golf cart. He's pulling the golf cart like this. Golf cart. He's pulling the golf cart like this and he's going along a circular track. He's not wrapping the golf cart around his finger and twirling the golf cart around. Is that the case?
No, sir.
Yeah. So he's like dhakka de raha hai. Okay, he's doing the. You think of a race track, and you're having to push someone around the racetrack. How is the push? There is a truck. You're pushing it straight, and the truck is moving like that, and then you're changing the direction of push to accommodate the circular motion, isn't it? So this is the work done W1. This is the work done W2. Here, this is the work done W3. So you sum up all the work done as you're moving throughout the circular track. Are you following this?
I'll take the entire circumference as the distance.
Yes, you have to take the entire circumference here. So you will say 2 pi into whatever radius are given.
You said 2, sir.
2 meters. 2 pi r is the distance. And I have told the, my mistake, guys. You don't need the mass of the golf cart because that's stupid. You need to get what is the force applied by this guy, okay? So let's say the force applied by this guy is 10 Newton. Okay, so you will say the work done is equal to 2 pi r multiplied by 10 Newton or 4 pi into 10 or 40 pi joule. Are you following this?
yes, sir.
Okay, so Riddhi, you picturize like this, okay? You have a cart in front of you and you're pushing the cart like you do on a straight road, okay? But only thing here is the road is not straight, the road is a circle. Okay, so you're pushing, you put one step, okay, and one step means you moved, let's say, half a meter. So that's, you've done W1, some small work, when the force and displacement were in the same direction. Then you turned yourself a little, and then because the track is circular, no, you have to adjust yourself. And then you move the next increment. You did component W2. Then you turned yourself a little and you moved. So like that, you think of the circular track motion as small pieces of work to be done in pushing the cart through small distances. Okay, so the overall distance you have moved, like in the steps, step 1, step 2, step 3, and you got total 5 meters, right? So like that, the overall distance you would have moved is 2 pi r, the circumference. Because at every time you are pushing the cart and the cart is moving in the same direction. You are pushing your sister on a cycle. So the cycle and your push are in the same direction. But overall, if you see, you have traversed a distance of 2 pi r, circular distance.
Yes, sir.
So this is again a common misconception. Okay, when you are tying a thread and twirling it around a circle, there the tension is the force and the object is moving, perpendicular to the tension. that is 0. But when you're pushing a cart, pushing a cycle, pulling a golf cart and going around a circle, please don't say work done is 0. Work done is F into 2 pi r.
Yes.
Aditya, did you follow this?
Yes, sir.
Okay, and there I will stop the class. I don't know, do we have time? 1 second. Can you get the time, guys?
Sir, it's 8:53.
8:52.
Oh, I'm so sorry. Chalo, guys. Bye.
Thank
Bye,
you,
sir.
Bye,
Thank you,
sir.
Bye,
sir.
sir.
Thank you,
Thank you.
sir.
Bye.
Bye.